All right, so this is section 5.5, part 1. We are going to be solving trig equations, and we're going to break this up into a couple, 2-3 parts. But basically, this first day is going to keep things basic. What we're going to do is we're only going to be using algebra, okay, to solve our equations. Eventually, we'll get to the identities, which we just finished up on, but we're going to start by keeping it as basic as we can using algebra. So to do this, we first want to recall the unit circle. I'm not going to have you guys pay attention so much to the coordinates on the outside as much as we just want to make sure that we understand converting our degrees and radians and where we're at on the unit circle to be able to locate quadrants, etc. So this next slide is going to be important because with sine, what we want to remember is that sine is equal to our y value. So if sine is equal to our y value, then we need to remember that sine is positive above the x-axis, so in the first and second quadrant, and it's negative in the bottom quadrants, the third and fourth. Cosine is equal to our x value, so we know that our x values are positive on the right, so the first and the fourth quadrant, and negative in the second and the third quadrant. And then tangent is equal to y over x, which is sine divided by cosine. And tangent will be positive in our first quadrant, in our third quadrant, and it'll be negative in our second and our fourth quadrant. And that is where we came up with the quadrant where we had the all students take calculus. Everything is positive here, positive, positive, positive. Sine is positive here, everything else is negative. Tangent is positive here, everything else is negative. And then cosine is positive in the fourth quadrant and everything else is negative. So that's where the all students take calculus came in. Now this is going to be important, and you'll see why when we do this first example. So what we're going to do is when we solve these equations, so here's the first tip. When the equation only has one trig function, okay, start by isolating that trig function. So because we only have sine, what we're going to do is isolate our sine of x. So to do that, we have to bring our 2 sine of x over to the other side using regular algebra. Minus 2 sine of x from both sides. And we end up with 2 sine of x equals the square root of 2. Of course, then we divide both sides by 2. And we have sine of x equals the square root of 2 over 2. Now, recall what we just talked about. We said that the sine is positive in 2 quadrants. So this is kind of what we did at the end of the last chapter in solving trig functions. So we're clearly trying to find what an angle is, and sometimes you'll need to use a calculator to find it, and sometimes you won't. In this case, what we're going to do is we're going to draw out the 2 triangles, or the 2 quadrants where we're good in. So if I draw a triangle in the first quadrant, because that's where sine is positive, and I draw out a triangle in the second quadrant, because that's the other quadrant where sine is positive, what I do is I can label my triangles square root of 2, because that's the opposite side of x. We're going to put x's here. And then we're going to put 2 on our hypotenuse, square root of 2, and 2. And what you want to do is you want to look at that triangle, and is there anything you know about that? Can you identify the angle that would be created with a square root of 2 and a 2 like that? And hopefully you realize that is one of our special right triangles, and you know that this x value is going to be 45 degrees. So we have 45 degrees for one of our answers. Well, we also know that our second angle is going to be 45 degrees. Now, that's not our answer. We need to know what is the angle going to be to get to that 45 degrees. So from the beginning to that 45 degrees is going to be 180 minus 45 is 135 degrees. So our second answer here is 100. Sorry, messing up a little bit here. So 135 degrees. Now, what we also want to pay attention to is, can we convert that to radians? So 45 degrees is pi over 4 radians, and 135 degrees is 3 pi over 4 radians. So any of these pairs would be your answer. Any of those work. We have no issues with either one. I'll try and make sure that I let you know whether we want the answer in degrees or radians. But the point is that we do get 2 answers here, and we do get 2 answers here. Okay? You don't need all 4 of them. It just depends on what the problem is asking you to give the answer in. Okay, but we should be getting 2 answers for each one of these because it works in 2 different quadrants depending on the trig function. Okay, let's go to the next one. Okay, the next one says 4 sine squared of x plus 1 equals 4. So again, we're going to solve this like a regular algebra problem. -1 from both sides. So we're left with 4 sine squared of x equals 3. Divide both sides by 4. So now we have sine squared of x equals 3 over 4. Take the square root of both sides. So we have the square root of both sides. So this is remember, when we take the square root of both sides, we need to do plus or minus. So we have sine of x equals plus or minus the square root of 3 over 4. We need to simplify this. Plus or minus the square root of 3 over the square root of 4, plus or minus the square root of 3 over 2. So now we're dealing with a sine function that is positive or negative. So if we draw out our quadrant, which of the 4 quadrants are we working in? Well, it's positive in these two, and it's negative in these two. So we're going to be working in all 4 quadrants here. So now we get 4 answers because we had a plus or minus to solve. So again, let's go to all 4 of our quadrants and let's draw our triangles. And all the triangles are going to be exactly the same, but we want to just make sure that we label them so that way we can identify what we think the angle is going to be. So opposite is square root of 3. The hypotenuse is 2, and that will be the same for all of them. So what kind of angle do we get with an opposite of square root of 3? We get 60 degrees. So 60 degrees, 60 degrees, 60 degrees, 60 degrees. So we just need to identify what each of those angles are. So we know 60 degrees works in the first quadrant. A reference angle of 60 degrees in the second quadrant will be 180 minus 60. So that's 120 degrees. In the third quadrant, it'll be 180 plus 60. So that's 240 degrees. And in the last quadrant, it will be 360 minus 60. So that will be 300 degrees. And then simply, if we wanted the answer in radians, then we would just convert these to radians. So we have pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. So either one of those answers would work, but notice now we have 4 answers because we get 2 answers for positive, 2 answers for negative, and we found out when we took the square root of both sides, we would get positive or negative. Okay? So essentially what we're doing here is we're taking the ratio that we have, we're seeing if we know it based on special right triangles. If not, if this is a fraction that you're unaware of, you can use a calculator, and you'll use the calculator to find your first angle, just like we did in the last chapter, and then you will use that first angle as your reference angle all the way around whatever quadrants you need to use it in, and find where your other angle is from there. Okay, let's look at our last example. Same idea. We want to isolate our tangent of x. So to isolate our tangent of x, the first thing I would do is minus tangent of x from both sides. So 2 tangent of x minus 1 tangent of x is just 1 tangent x minus the square root of 3 equals 0 now. Now we add square root of 3 to both sides. So we have tangent of x equals the square root of 3. Now keep in mind, square root of 3 would be like over 1. That's how we get our 2 sides. Now let's look at our quadrant. Tangent is positive in the first quadrant, in the third quadrant. So that's where we draw our triangles. And then now let's label our sides. Opposite over adjacent. So again, this is a triangle that should look familiar to us. The square root of 3 is always opposite of our 60 degree angle. So we have 60 degrees here. We have 60 degrees here. So to get the angle that goes all the way around, we get 180 plus 60 is equal to 240. So our 2 answers here are x equals 60 degrees and 240 degrees. And in radians, that is pi thirds and 4 pi thirds. So hopefully this first basic step of solving equations makes sense. It will certainly get a little bit harder once we start throwing the identities in there, but obviously that doesn't help to do that until you guys understand the clear basics of this. So I hope this makes sense. I will see you in class, and have a good night.